So recently I was asked to do a white paper and discussion paper about the future of underwriting and the application. And yeah, so I just wanted to share the ideas. It's just a conceptual paper, and I just want to see what people think and love to get their feedback about the concepts and how we can make better underwriting, better funding for the future. So the concept here, we're just discussing how underwriting and especially in the funding space can be improved using AI. So you know, the situation today, underwriting is something that's very static. It's you know, we have our static segments. We're doing an underwriting based on a current situation. What do we know about the business, the information business, their past performance, and we're taking a very static view. We're not looking at how the payments are happening and a lot of interactions. And also something which has come about is that the models are changing. So, historically the models are very static, but with COVID, what is a good business, what isn't a good business has changed pretty dramatically. So we need to factor in these changes and how businesses are evolving, what is good business, what is bad business, and how this kind of factors into underwriting and what we know, and what we can learn from the environment. So a little bit about where these ideas come from. So I I put three examples here. Roomba, which is a vacuum cleaner. This vacuum cleaner has the ability to learn about its environment. It's a goal-driven vacuum cleaner, which means it's trying to optimize the amount of space that it can clean without running into objects, without using all its battery. Um, and it's trying to evolve. So as an environment such as a room, which is not that static, tables can move, other features can move. How can it optimize its rewards, and how can it clean more? Another example of where this is coming from is DeepStack, a very interesting project. This involves basically playing poker, but at a superhuman level. And the beauty about this project is poker is not, once again, it's not something that's static. I mean, the way you play poker is not looking at information at a single point in time. You need a strategy for every hand. So especially this is Texas Hold'em. So as you go through the sequence of cards being dealt, the betting rounds and things like that, there's a lot of strategy, from bluffing, from optimizing your stack and how you execute. So DeepStack was able to create a model which went above superhuman levels to win at poker. Alpha Star, this another super interesting project by Google, which has taught a computer to play a game. So to play StarCraft, and this is a strategy game. So it's well beyond just a simple seeing the board, knowing exactly where everything is. It involves so many more aspects. It involves exploration, um, you know, combining resource management with aggression, with defense, and other aspects. And this is a great project of using competitive reinforcement learning to create an environment. So where this motivation came from was seeing the success of these other projects. And here is an example of, it's just a screenshot from AlphaStar, um, where you can see that here they're taking in observations, like a human-style observations. They're passing it through a series of neural networks which have been trained, and then making poor decisions. So they're factoring a lot of things: observation, time is factored in, strategy is factored in all this combination of activities. So what is different about these? So we have our stats models, we have our AI models, which are very much looking at single points in time. They're mapping an input to an output. But here we can view underwriting and we can view like a funding process as episodic. So it's something that is based on time. It's not just something that happens once, it's something that you need to create a process over time to achieve a result. So in many situations, like as I said in poker, it's the betting round, it's the next card round, it's a sequence of events. So something that might happen earlier on, which may appear not to be advantageous, may end up more advantageous in the end. And an example of this is in poker. Maybe you have the optimal hand, but betting a lot in the beginning may show evidence that you have a good hand. So hence you're not going to get the best return on your investment by betting heavy in the beginning, but maybe it's better to have a strategy where you bet low and you build that up and you encourage others to bet more aggressively to optimize your return on that hand. So this is one key difference in thinking about this learning. And the other thing is to treat the system as an environment. So what we're talking about here is we have the journey, which is often referred to by an agent as taking that journey, which is interacting with an environment, and then we're going to get back some kind of state and reward. So what we're trying to optimize is the reward over time. What is the best thing that we can do over time, not necessarily in a single point in time, but over time. So here I've done another example of a journey. This is a computer game, so obviously it's fairly easy to see. We have a path from the starting point and we want to get to the ending point. So what actions do we need to take in this case to optimize the fastest way to get to the end of the track without dying? So this is what we're talking about, that we're viewing underwriting as a journey. So there's different types of journeys which we could view underwriting as. We could view it as onboarding, performing the underwriting, sending the funds out, performing the collections, and at the end, the renewals. So this can be a journey that we might look at. And how do we describe that journey? So one of the methodologies that we use is to describe the journey as a BPMN model. So this is a business process model which is executable. So it's where, this is just an example, but where you can see where the starting point of the journey is, the human interaction, automated features, the key decisioning, and obviously the events which occur. So this creates a business way of describing a journey to describe an environment which is going to happen and the journey will happen through. So having this now we have an environment, we have the process of the applicant or the business who wants to get funding or go through underwriting. We want to optimize that strategy. So I'm going to give a couple of examples of this in a more automated, kind of easy consumable way to think about it. So here we have the idea of onboarding, and this would not just apply to underwriting, it would apply to any industry. So let's take a theory here that we have an environment which is the sequence of actions to get a customer onboarded. And we can think of two different types of customers. So let's think of a customer is a very creative customer. They like to be talked to. They like to know about the benefits. They like to know a lot of information. And then we can take another customer which is very technical. They just want to see the numbers, the figures, and then only at the end when they have some questions, maybe they want to interact. So having these type of personalities allows us to see this as an environment. So maybe in a A/B testing environment or a static environment, we would just be able to create a single path and we optimize the message for the general population to get the best result. By using this example, we treat it as a environment with rewards. So our rewards here may be just to get the maximum number of signups. So we can perform a series of actions which may seem counterintuitive, but in the end, perform the optimal result. And that's very similar to the poker. So in this diagram, we have this idea. First, we gather some information about the user. So we're collecting information about who they are, what they are. Let's say they're professional, they're, where they live, maybe some cultural information if it impacts, and some other kind of general information that's going to tell us about the person who is going through this onboarding process. And once we go through this process, let's just say we first send off an initial message, thank you for applying. And the system will make a judgment. They will judge the reward from doing that certain action. Obviously, the ultimate reward is to create the onboarding to get them onboarded. So the system will create a single step in an episodic system, and it will perform this action. Next, it will see if the goal is achieved, and then if not, it's going to gather information in the environment, and that may be, have they filled in all the information? What information have they received? So this environment is changing. And then using the reinforcement learning, they're able to predict what is the next decision to be made. So going back to the example before, the actions that we had were, we have a technical person, they just want to know information. So maybe we just send email one after the other, very close together. We're sending the more detailed emails. And then once we've gone through a process based on how they're interacting with those emails, then we book the meeting to do a final call, and then make that decision and push them to the sign up. Alternatively, someone that needs a little bit more time, maybe we need to allocate more calls. So the beauty of that journey is that it's just evaluating the environmental data, what it knows about the person, what it knows about information that's been sent, what it knows about what needs to be collected to be able to perform the right onboarding decisions, and then feeding that back to the model. And another great aspect of reinforcement learning is that it's performing experiments. It's not just making a single decision and always going with that decision. It's always trying to optimize. So as we can see in the vacuum cleaner, as you move features around, it's going to keep discovering these new spaces that just suddenly opened up, which is increasing its reward. So once it kind of, it will knock against something and say, oh, that table that used to be there is not there anymore. I have more carpet that I can clean. So I'm going to keep on increasing my reward. So the same applies here. So we send a message, we learn about the people. So as we discover people that we haven't seen before, different personalities, maybe we need new information, maybe there's different products that we need to offer, the system can explore the alternate paths and try to create an optimal strategy there using a combination of known predictions and exploration. And the beauty here is where traditionally you're going to see onboarding as a static thing. We A/B test a process and we create a single model and single workflow for onboarding. Here, it's customized and optimized by personality, and the beauty, it's learned by the computer. So we don't need to manually tell it what interactions need to happen when. We don't need to tell it how much time to wait. it can learn the strategy of the best results, best time to send, when to send, and other things like that. So this is an example of how this reinforcement learning and AI can fit into the onboarding. And just with this very simple diagram, get complex decisions. And of course, once the system has learned a certain sequence, it can extrapolate the sequence into a linear workflow diagram. So it's a sequential. You can visualize and see how the system has optimized this strategy. The next one I'm going to talk about is a theoretical loan product. So because it's a reward-based system, we can talk about how underwriting. So we see funding a customer as something very like, okay, these are your terms, this is your monthly payback. So let's talk about a theoretical one, that we want to create a product, a funding product, which is optimal for how the business performs. So we want to set a reward. First, the business pays back and with maintaining a certain liquidity. So we want to make sure that they optimize their paybacks, but that they always have enough liquidity all the time for the future to be able to pay something back. And from the other side of the reward, we might say from a funding partner, the reward here is how quick these funds are returned. So the quicker they return, the better, the better the reward. So, these are, by combining these two kind of rewards, we're trying to optimize the best strategy of how payback could be. So in this theoretical loan product, we have a payback, a liquidity thing. So in the beginning, we see a large dip. So the business has been waiting to get this funding product, and they've been saving why they're waiting to get approved for this funding product. So they have some cash and they have a high liquidity. Once these funds come and they have their savings, they spend all this. So, they might need to buy some infrastructure, buildings, whatever it's going to be, but they have a heavy spend right at the beginning of the product. So maybe at the beginning of the funding product, the system can optimize their strategy to lower the payback at that point in time. Knowing the environment, we're going to expect to see, okay, there's going to be a pickup in the liquidity. They've made this investment, they start getting a return on investment. So at what point do we actually excel the payback? So we want to optimize the payback. So we're actually, rather than the standard payback, it's going to end up going much, much higher than the standard payback. So during a period of time where the business activity is very healthy, then paybacks are maximized and increased to maintain those funds getting paid back, lowering the rates for the customer and obviously paying back the funds. And let's say we know a situation where liquidity, maybe it's the end of the year or at a certain point in time where there's a lot of expenses. Knowing this environment means we can optimize this theoretical loan product to maybe the month before or whatever to predict that liquidity is going to be a problem in the future. So optimizing that strategy to then decrease the payback. So all businesses have this style of life cycle, maybe not this one as a theoretical one, but they all have certain impacts. Months of expenses, months of good growth, and other kind of seasonal aspects, tax aspects, and other things which create these curves and trends. So having this kind of concept of a dynamic funding product, it's only theoretical. It's only for discussion of how reinforcement can look at what has it done in the past, what is the environment, and how can it optimize the strategy for the future based on the environmental factors, what it knows about the businesses, about the business liquidity, about the blank flows, the assets, as well as other factors such as government trends, industrial trends, and other kind of information. So it can optimize a strategy that works both in the business's favor and also in the funding partner's favor to get the best results. So, in conclusion, the idea here is that, viewing funding and underwriting as a journey allows us to take another approach of how it can be optimized. So instead of optimizing single points in time, we can look at optimizing what is the best strategy for the journey, for the underwriting and, in this case, funding through that whole journey from the start to end. What is our ultimate rewards? What is our environment? And what is the goal? So making some decisions which may be less optimal in the beginning may lead to greater rewards in the end. Um, Using a reward-based system means that the journey can be optimized based on what we consider to be good. What is good for the business? What is good for the underwriting? What is good for the funding company? So optimizing it based on rewards means that we can set mutual goals which are beneficial. So we're optimizing something where it's a win-win situation, and where we're looking at the environment as something that's a lot more dynamic and where decisions can be made. The other thing is using this type of reinforcement algorithms, we can use exploration to continually improve. So, as I said, COVID's been a perfect example where good businesses have become bad businesses have become good businesses. So, given a stream of data, a changing environment, we can now kind of optimize for that environment. We don't need to be static in our view, and especially with the next years to come, what is going to happen in every country and how that's going to affect businesses will really require a continual improvement aspect to it. So being able to explore, perform variations on a strategy, and then working out, did that get more reward for me, or did that in the end give me a negative reward? Was it more beneficial or non-beneficial to me? So that allows for models like we used in the vacuum cleaner or the poker hands, allows models not to be a static element, but more of a dynamic element. And that's it. So hopefully that understands, and I would love to know if you believe this is the future of how underwriting will happen, and if these are good strategies moving forwards.